Alright, so let's take a look at this objective. Scholars were able to find the length of a segment on the coordinate plane by using the distance formula, okay? And we're also going to be using not just simply the distance formula, but the Pythagorean theorem as the concept, okay? So let's take a look at this first question. We already did this, the square root of 32. The best split for this would be square root of 16 times square root of 2, and it simplifies to 4 root 2, okay? Root 72, let's just say you didn't know any better and you did root 9, root 8, it's still fine. It's going to give you 3 root 8, but then you want to simplify root 8, 3 root 4, root 2, and then 3 times 2 root 2, which makes it ultimately 6 root 2, okay? That's what you get as the final answer. So let's go through this. Distance formula. Length is how long a line is, okay? L for length, L for how long a line is, okay? Distance is how far apart 2 points are. Okay, so far so good, very straightforward. The distance formula. So to find the distance between 2 points x1, y1, x2, y2 on the coordinate plane, this is the distance formula, which I already introduced you to the previous video. I'm sorry, what is this? The distance, right? The distance between two endpoints of a segment on the coordinate will result in the length of that segment. So if you solve for distance, you basically solve for length. So let's take a look at this. Find the length of ST on the coordinate plane 7, 3, and if S is 7, 3 and T is 5, -1, right? And write your answer in simplest radical form. So let's take a look at this. We don't have to graph it, but for the sake of this, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So that's S, 7, 3, and then T is 1, 2, 3, 4, 5, -1. So that's T, okay? So, and they're trying to ask us to find the distance, the length of this line, okay? It's pretty straightforward. I'm going to show you both ways using the distance formula and using the Pythagorean theorem. And in fact, let's use the Pythagorean theorem first, okay? I see this line, so I'm going to just drop a little triangle so that I can see exactly what the change in y and the change in x, basically, or the distance it takes to go from here to down here, right? And you can clearly see that it's going to be 1, 2, 3, 4, right? And this is 1, 2, okay? So change in y, or you could also think about it as 7, 3, 5, -1. To go from 3 to -1, you are subtracting 4. To go from 7 to 5, you're subtracting 2. In any case, if this is the change and this is the distance, right? Basically, we're going to square it anyway. So let's just do a squared plus b squared equals c squared. A squared plus b squared equals c squared. You're going to do -2 squared plus -4 squared equals c squared. That's going to give you 4 plus 16, again, equals c squared. 20 equals c squared. Square root, c is equal to square root of 20. Of course, we can't accept this answer because this is not simplified. So c is equal to root 4 root 5. And c is equal to 2 root 5 as the final answer. Okay? That's how you would use the Pythagorean theorem as a concept. If you wanted to use the distance formula, you would actually have to label this x1, y1, 5, -1 as x2, y2, right? And then from there, use the formula. D is equal to square root of, let's do 5 minus 7 squared plus -1 minus 3 squared, okay? D is equal to -2 squared plus -4 squared. D is equal to 4 plus 16. D is equal to square root of 20. And square root of 20 can be simplified into, this can be simplified into root 4 root 5. D is equal to 2 root 5, okay? Two different methods to get the same answer. Pick whichever method works for you.